In our earlier discussions, we discovered that if we took f of the inverse of x, it would equal x. And likewise, if we took the inverse of f of x, likewise it would equal x. Well, those compositions can also hold true in our sine, in our cosine, and our tangent functions. So that if I have the sine of the inverse of sine of x would equal x, the inverse of sine of the sine of x would equal x. Those particular compositions within our trigonometric functions, they're going to be a little bit more tricky than they were earlier. And the reason why is that we have some restrictions on what those input values would be. What are the interval where I would find my x at? So for example, if I took the inverse sine of the sine of pi fourths, well, what would that equal? Well, I would look at my identities here, my composition identities, and I see that this is the sine of the inverse sine of the sine of x. Well, that's always going to be x if x is in my interval. This is where it's different. In my interval from minus pi halves to pi halves. Is my value here within that interval? In this case, it is. So my result then would be pi fourths. However, that's not always going to be the case. Let's look at another example where we're going to have to do a little bit more lifting to get to our result. The inverse sine of the sine of 5/4 pi. What does that equal? Well, we look at, first of all, is our argument is that within the interval. The interval says that I have to have values between negative pi halves and pi halves. Well, 5/4 pi is not within that interval. So what we'll do to proceed then is remember a little bit more about our reference angles. So do you remember what the sine of pi or 5/4 pi was? Well, that's in our third quadrant, and its reference angle was pi fourths. So that would equal sine of pi fourths, but it was in the third quadrant, so it will be negative. So these two ideas are the same. From there, we can find out what the sine of pi fourths is. What's the exact value of the sine of pi fourths? Well, that was a root 2 over a 2. And then I have that negative. So the sine of 5/4 pi, its value is negative root 2 over 2. I can take that value now and take the inverse of that. And if I can remember its exact values or look at my chart to figure out what's the exact value or the angle that produces this value, that was a negative pi fourths. So when I look at some of these compositions to begin with, I have to pay attention right away to where is its interval. What are the values of x that are allowed to be in the interval? If my value is not within an interval, I need to do some work beforehand, like finding a reference angle, then the exact angle, or then the exact value, and I can then use that to kind of not really restrict the domain, but to narrow our search a little bit and to put it within our range of, or within our interval. Then from there, it's just matching up values with the exact values on our tables. All right, so you want a few more examples? Not quite there yet? Yeah, I don't blame you. Again, like a lot of these things, it's new to us. So it takes some practice and getting used to of what we're doing and where we're going. And I know it's very confusing as we begin to explore some new ideas. So let's look at this example. The cosine of the inverse cosine of 0 or 0.6. What does that become? Can we use our inverse property here? Well, to begin with, we think about this value and identify is that value within our interval for our cosine compositions. Well, the cosine of the inverse cosine of x equaling x, that's true if I have x's within the interval of -1 to +1. 0.6 is within that interval. So therefore, I can use the inverse property right away, and then its result is a 0.6. That one is fairly easy. All we had to do is identify and make sure that my value of x was within the interval. If that's the case, it's just moving that along. The inverse sine of the sine of 3/2 pi. Let's identify, is our value or our x in this particular case within the interval? I have to look, the interval is from negative pi halves to pi halves. 3/2 pi is not in the interval. So what I first need to do is find the value of the sine of 3/2 pi. And you remember what the sine of 3/2 pi is? That was a -1. So now I'm left with asking is, well, what's the angle that produces a measurement of -1? Or whose sine is a -1? The angle of that particular case, if we remember our table, would be a negative pi/2. So my result then of the inverse sine of the sine of 3/2 pi, I couldn't evaluate it right away. Therefore, I had to first evaluate the inside argument, and that produced a -1. And now I'm asking whose angle makes a sine of -1. The angle was negative pi/2. Now, I want to say more about that because I know where you guys are getting stuck on this. You're simply getting stuck on trying to figure out, how do I know that? And that becomes, again, with remembering our values, our sine values, as it worked our way around the unit circle. It's just one of those points that pops up often, so it's one that we begin to commit to memory. And lastly, I want to look at the cosine of the inverse cosine of 1.5. Look at my 1.5, look at the argument. Notice that my interval is from -1 to 1. That tells me then that 1.5 is outside that interval. Being outside the interval tells me then that the cosine of -1 at 1.5 is undetermined. It's undefined. And if this is undefined, then the cosine of something undefined is undefined. So this result right here is just undefined.